So I think the best answers are the second and third. No is hardly ever a good answer to a question about is there any possible way to break something. The way the adversary would learn that Dave and Alice are communicating is if there's a way to match up the messages at the endpoints. So this would be the case if there's no other traffic that looks similar on the network. These messages aren't the same. Remember that they're encrypted in different ways, that this message will not look similar to message 1, but they'll both be encrypted messages. They might be similar because of the length. There might be things the adversary can do to adjust the timing. Remember, this is not a direct link. So the adversary, if there are many messages going between Alice and Bob, could introduce delays in the messages and see the same pattern of delays on the upcoming messages. That would work if there weren't any unpredictable latencies inside the network. So if there's any way for the adversary to correlate those incoming and outgoing messages, then the adversary would know these two parties are communicating. If the adversary can see all the traffic on the network, this would be a very powerful adversary. Well, that's not enough unless they can correlate it. So even if an adversary could see all the messages coming in R2, if there's many other messages coming in into R2 at the same time and many other messages going out of R2, if the adversary can't connect the ones coming in with the ones coming out, well, then they wouldn't be able to follow the chain. So in order for this to be secure, we need to know that there's a lot of other traffic on the network that looks similar. So you'd like to know that between all of these routing points, there's always messages going. They look similar lengths, similar timings. There's no way to correlate the messages that come in to one router with the messages that go out from another one. So this is one of the things that you need to do to make a network like this secure, is to make sure that there's enough traffic. You can inject a lot of fake traffic. That's expensive. You're wasting bandwidth on things that don't go. And you've also got to be careful to make the fake traffic look like real traffic. So you can't just send random packets. If there aren't correlations between those packets, and if you're not sending a full flow, well, then that could be detected by the adversary. So there are lots of hard problems to solve to make this secure. There's a very successful project that provides this as a service on the internet. It's called Tor. You can download it as an extension to your web browser. It provides a way to connect to a website without revealing to the website where you're connecting from. You need to get a response as well. And so that means in addition to selecting the route for reaching the website, you need a route for returning. You don't want to include your IP address, so that would reveal your location in the response, but you want to get the responses. So what this does is select routes in both directions. Selects a random set of routers to reach the website that you want to communicate with, as well as a way for that to send a response along another random path.